Welcome back, everybody. In this video, we're going to be diving into our next access rule topic, which is going to be trying to optimize the configuration. So if we were to look at our command line here and do move my mic out a little out of the way here, show run access list, and then a show, you can see we have the ACLs that we mentioned from the previous video. So we have ACL trace, we have ACL RDP, in from outside, global, and out from outside. So what we can do now is we can take advantage of what they refer to as access or objects and object groups, which will allow us to optimize the ACLs and stuff like that that we're trying to configure. So I'm going to go ahead and I'm just going to clear configure access list, and then hit the enter key. It's going to clear all the ACLs. So show access list. All the access lists are gone, and I'm going to say clear configure access group, and so show run access group. So all the ACLs are gone now. So we've got a fresh config. So now what we can do is take a lot of the same processes we were doing in the previous video, except for this time now what we're going to be doing is taking and leveraging groups of which are going to reference different things. So instead of us referencing, for instance, a particular prefix or a particular destination or a particular service, we're going to allow individually in the ACL like we were. What we're going to do is we're going to take advantage of grouping that together. So let's talk briefly about exactly how this works. So I'll go ahead and pull up my pen pad. And so inside of our network here, we have the DMZ, which is basically this part of the network right here. Let's draw this a little bit cleaner here. There's pretty much this part of the network here, and we have the inside here, and then we have the outside. Everything above here is outside. Well, what we can do is we have the DMZ, we have two destinations, and we can have lots and lots of services running, which could be a combination of, or more than likely going to be TCP-based applications or services that are running, but it could be UDP if they're also, so potentially running voice over IP or things like that. So what we can do is we can take advantage of grouping objects together. So we could say, because we have two different subnets, we have the 172.16 network here. That's just horrible writing. We have the 172.16.30 network here, and we have the it's all under one. So let me write it up here. So we have the 172.16.30. How did that happen? My pen tool went away. That does happen every once in a while. Sometimes Windows 7 gets a mind of its own. .30.0. All that resides in here, and then we have the 10.100.0.0/16. So everybody agrees with that. So then we also have a number of prefixes up here that we could potentially have. Now we're not going to get we could get granular, but we're going to take this in respects towards we could have multiple sources, multiple destinations, multiple transports, and multiple services we're trying to reach. With all that in mind, let's say for instance that all these locations were able to communicate with this location. So we were running NAT here, and server 1 was able to talk to server 2, or whatever the case might be. So an example of how this would work is if I create an ACL like we did in the previous video, we would simply type in ACL, we'd say the permit statement. I'll just permit and then the transport, let's say TCP from any to any, as long as it equals to 80, which basically is permitting web communication, right? Well, that's fine, but if I have multiple sources and multiple destinations that I need to match on, I have to create an ACL per entry. And that can get a little long in the wind. So instead of doing that, makes more sense to create objects. So you have, the way that the hierarchy works is you have the object. So actually you have the ACL, the individual ACL entry. Then you have the object. Then you have the object group. And the object group is simply a grouping together a number of objects together. So objects would be, you could have multiple objects created and then call all those individual objects from a single object group. So it's a way to build hierarchy. Now inside these objects you have both network and you have service. It's not limited to these, but these are just a couple of the more common things that you're going to do. Now when you create this, you can create a network where it can be this can be a range, this can be a host, or this can be a subnet, however you want to do it. And as you're going along, you'll, especially when we get into basic NAT in an upcoming video, you'll see how using the object you can specify as a host and then create NAT statements. Now for the service you can do a couple of different variations here. You can do TCP, you can do UDP, you can do ICMP, so on and so forth. So it gives you a lot of flexibility. Now once we are working through creating all of the objects that we need, then it'll come up to a point of, okay, well, what else can we build off of this? What other options do we have? So when it comes to an object, we could do this per VLAN, which is one object. So we can create, we could say object, we could say VLAN 10, and then we could say underneath VLAN 10, we create a subnet of 10.100.10.0/24, and then do an object of VLAN 20 and do 10.100.20.0/24. That's a couple of objects. We can also do another one for the DMZ. So we could say object DMZ, and then we could specify 172.16.30.0/24. We've created our objects, and then we can create an object group. They would say, like down here we could say object, I cannot write, object group, and we could specify inside, and then we can specify object, I don't know why I keep writing it backwards, B, object VLAN 10 and object VLAN 20. Now we've got that created, and then now we can have specific other objects, and then we can have a you can mix and match too. You can have a defined source and destination, so you don't have to call an object. You don't have to have two objects. You don't have to call two objects from an access list in order for it to work. You can have a permit any to object inside, for instance, or permit any to object DMZ, and it's going to work. Now the other one we can do is we can do the object group per service. So we can create the object of TCP, where it's going to be a port object, where it's going to say what port are you, so what's the transport, so TCP, UDP, whatever it might be, might even be an FTP flow. And then you can go in there and say, okay, what TCP port do you want to match on? We could say 80 or 23 or 22 or 443 or 3389. Whatever we want to match on is up to us. and then we could call that. It's no different configuration-wise than what these objects here, and then you can nest those as well. And then you would simply just create access rules to build off of them. And that's the benefit here. You're able to scale it out to where your final config would be access list. You could call it ACL in from out example. Now I'm going to continue this line down here a little bit, and we could say permit, and we could say I believe the service object comes before. I'd have to double check. I'm pretty sure the service object comes before. It might come after, but normally you'd say permit TCP. But we'll say we'll take a look at the service object afterwards. I just want to see if there's a. I'd have to actually walk through the CLI to see if there's a if it matters. But permit TCP. If the source would be, say, any. And then you could say object, and you could say inside, and then you can specify if it's going to say the service object of web, and do something like that. That would be your flow. And then, but it would be calling an object. You'd say from the inside object if it matches the web object. So we'll take that logic and we'll go ahead and apply it here. And really, when it comes to scaling it, this is pretty much about as far as you want to go anyway, because you can get pretty complicated with the object groupings, and so we want to keep that in mind as we're going forward. So what we're going to do is pull up the command line, and we're going to bring this down just a little bit. And scoot this guy up a little bit, and we're going to go ahead and pretty much build what we just wrote. So we're going to create an object. The object is going to be a network object, and we're going to come in here and type in VLAN 10. We're going to come in here and specify a subnet of 10.100.10.0. I believe I can do a slash notation. Yeah, so it's going to be 255.255.255.0, and then I can exit out and I can say VLAN 20, and then same subnet design 20. If I do a show object, notice how it does object group and there are no objects. You have to actually do a show run object in order for it to pop up. So then we can go ahead and create another object that says object network is going to be DMZ, and we can type in subnet is going to be 172.16.30.0/24, and we can exit out. And so we do a show run object, and we have those three objects created. Now I can create an object dash group called inside, or sorry, which is going to be network, and I can specify the name is going to be inside, and underneath here I can specify network dash object, and then the name of the object is going to be VLAN 10 and VLAN 20. Then if I do a show object group, there it shows up. So it's able to, so we've already nested it. So you're taking an object that calls a the object calls a subnet, or whatever it is you're calling. It calls something, and then the object group references that object, and then you're able to scale it that way. Now I can also exit out and type in object and say service, and I can specify the service name is going to be, we're going to go right now with, we'll say telnet, and underneath here we're going to say service, and we're going to specify is going to be TCP, and we're going to say the destination is going to be equal to 23. Okay, So then I get to hit the up arrow and I get to type in SSH, and I can come up here and I can type in 22. I can do show run object, and you can start to see how it starts to scale this. I can do another one here that says dub dub dub, and I come in here and I say as 80. Or I can do a range. I can, in this case here, I think I can do dub 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 and that's it. I can do a range either, but I would likely say www, or I'm sorry, dub 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 for just regular web, and then another object that says HTTPS. So that's how I would do it, and go from there. And then there's FTP and so on and so forth. And then you can, so I'll just type in www, or sorry, is equal to HTTP, and then I'll do another one that is HTTPS, and I'll come in here and I'll say that that's HTTPS. Show run object. As you can see, I have plenty of services now, and I have a couple network-based objects. So with all this said, I can go ahead and now look at trying to join all this stuff together. So I can come in here and type in access list, and I'm going to say ACL underscore in from outside, and I'm going to say it's going to be an extended ACL. Why is that? And it's going to be a permit statement. Why am I show run access group? That's weird. All of a sudden, no logging enable. I don't really want to see that right now because I'm busy trying to walk you guys through the config. So we're going to continue doing this. We're going to say permit, and then now we get to call the object. So and you have to remember the, if we go to all the way down to the bottom here, there is going to be a, I believe we call the service. And we might have to tweak the order in which the objects are called, but I'm pretty sure it's, it could be at the end, it could be at the beginning. I know we specify the transport now, and so we can go, and I'm going to go with, I want to allow I want to say TCP, but see the problem that we're running into with, as soon as you say TCP, you need to call that in. So it's actually, I shouldn't have to specify that because I've already called objects that, service objects that have already referenced TCP as the flow. So I shouldn't have to do this. So I'm going to say permit object, and I'm going to say, oh, and it's object service. So I'm going to say, what is the, I know what, I didn't group them together. That's part of my problem. So let me do this, show run object. I didn't group them together. So these are all TCP flows. So I'm going to create an object dash group called service, and I'm going to call this guy dub dub dub, and I'm going to say that hit the enter key, or I'm going to say TCP is the flow, and underneath, oh, I can't do, okay, so object dash group service, and I'm going to call this guy web, and say it's a TCP connection. And underneath here, I'm going to say port object, and then the, where's it, group object, and then the idea of the existing group. So I should be able to say www or HTTP. So let me do a show run object. So, okay, so this is one of those things where for web or communications like this, we may have, this is where I get a little confused on exactly the operations, but here we're specifying the port object. So we'll say port object, and we'll say is equal to HTTP and HTTPS. So show run object dash group service. Okay, so it did take it. Cool. So we're good to go there. So that's the first thing that I want to do, because now I can go ahead and exit out now and type in access list ACL in from outside, and say extended permit, and we want to call the object dash group, and the name of the service object group is going to be, we just created it a moment ago, which is going to be web, and we say so that is added to the end. So unless we define TCP up here, permit TCP from the object or object from, this is going to be any source, so TCP from any source to an object group of HTTP, and then we, so this is where it gets a little weird on how you want to, unless I need to do, let me back this up here, permit object dash group and then web. Yeah, see, it's a little weird on how it goes. So I would be better off saying permit TCP from any source to an object group of HTTP and hit the enter key. Original group HTTP show run object. I don't know why I'm putting in rub. Show run object dash group. Oh, oh, that's because I'm calling the wrong one. I want to call, not that, I want to say inside. And do that. So now that's the access list. So show run access list. And we have the ACL created. And then we do it, just go in here and type in access group. And then the name of the access list. And say in interface outside. Okay, and then we do a show access list. And and then when you do a show access list, it shows you the individual objects. So basically, it uncouples it, and then it says, okay, here's what you should be able to communicate with. So now I should be able to go and open up Firefox and type in 10.100, and I should be able to get a connection to, and I do, so I'll type in Rob and Cisco, and I have an open connection to IOSB 9, and if I hit the up arrow and do, I have an active hit on that particular prefix. Now if I go and do show con long, it's probably going to be closed out by this time, which it is. So I'll just go ahead and do a show tech support and hit the up arrow and do show con long, and there it is. So we know it's working because of the fact that the this config pulled up and we know everything else is working. So I'm going to go ahead and just back up here, and then I'm going to go to I think test 11 has show run section HTTP and user. Okay, so I have a username, but I don't have IP HTTP server, and then IP HTTP authentication is local. So now I should be able to plug in here now 10.100.20.11 and Rob and Cisco. That pulls up as well. And then I come back over here to the ASA. I hit the up arrow a couple times, show access list, and I get hits on both. So that tells me that the object group is working as it's expected to, and works as designed. So now that's inside, or from the outside to the inside. Now if I wanted to do from the DMZ to the outside, or from the outside to the DMZ, I could do the same thing. I would just reference a different object. I would say the DMZ object. So if we do a show run object, I have the DMZ object defined, and then I could specify another access list. But see, here's where you run into that problem again. Now I would have to go in here and from the inside, or from the outside, I'd have to put underneath this ACL that logic. So I'd have to type in access list, and then the name of the access list is ACL in from outside, and I'd have to come in here and type in extended and permit, and then specify the permit the TCP from an any source to an object of DMZ, and if I hit the enter key, it's going to permit everything TCP. If I wanted to go in there and be specific, I could, and I can just do that, and then do a show access list, and then I have it saying permit TCP to this destination. So I can come in here and say 172.16.30.10, and that pulls up. I hit the up arrow, and I have one hit on that access list. So I know the flows are working the way that they need to. And I can take the same logic and apply it in from the DMZ, so on and so forth. So what gets a little weird, and it's one thing that I've always struggled with, is doing the logic for the service. So the idea would be these services. So it should be where you're calling. So let's do it this way. We'll say we know what we're trying to get to. We'll go from the DMZ to the inside. So we'll type in AC or access list, and then the name of it's going to be ACL in from DMZ, and we'll come in here and type in extended and permit, and then we'll say an object. So this is going to be the source, permit object, and the object is going to be, and see it says right here permit service object. So we have to permit TCP from an object of the DMZ to a destination of the object dash group of inside, and we need to call a object group of service, and the object group service that we're going to be calling is going to be web. And so if we do a show access list, now you see how it comes into play, and it says permit TCP as long as it equals to, let me scoot this over just a little bit so I have more real estate here. It didn't like that. Hit the up arrow, and where it says web HTTPS, so it's saying 172.16.30/24 going to 10.100.10/24 equal to web HTTPS, and so on. But if I wanted to do another one of those, in this particular case, I could come in here and type in, I don't have an object group for Telnet or SSH. So I'd have to go and create a service object like I did before to call those, or create another reference on that ACL that matches those specific things. So I could come in here and hit the up arrow and go and do pull this out. But I could say at the bottom here, I could say equal to, say, 22 or 23, something along those lines. So show access list now, and it's going to add those entries at the very bottom. But you see how the ACL, the logic in it gets extremely long, because now it has to unpackage all of that, and it gets a little complicated to read. But now if I go to that server and I click inside of here, and on the web page, if I come in here and I type on 10.100.10.9, it should pull up, or not. And I'm not allowing ping either, so I shouldn't be able to ping 10.100.10.9. That should be dropped too. So I can add that as an entry. I can come in here and say, let's see, permit ICMP, and hit the up arrow, and that should allow it. Let's see what's going on. Show con long. Do I have that entry showing up? No, I do not. Why is that not coming through? So from test 9, I should be able to ping 172.16.30.10, and I can ping that way. That's really weird. Show on the ASA, show access lists. So at the very bottom here, I don't see any entries for ICMP, and the other ones here, I don't see any matches on them either. Oh, you know what? Show access group. That's why. Forgot to apply it. Access group. We'll say ACL in from DMZ. I'm like, oh, I did all this work. Why is it not working? In interface DMZ. Let's try that now. So we'll hit the up arrow and we'll hit the ping. So now it's working. And we'll try that one more time. There it goes. We'll do another one. We'll say, 10.100.20.11. That one pulls up as well. Rob and Cisco. Okay, so that's pulling up now. Show con long. And so obviously we timed out too fast, so it didn't catch. But if we pull up the real-time log viewer, just log connection lost. Oh, that's because I turned logging off. That's why. But as you can tell, the ACL is working. If we do a show access list, it is working, and it's working well. If we ping to 20.11, that should also work. And we have pings going to 20. Yep, that's all working quite well. Now we're not doing anything HTTPS, so if we wanted to add HTTPS to this, we could. It'd just be a matter of enabling the HTTPS service and go from there. So as you can tell, it does work. It just gets a little long in how it actually comes together. So if we just recap what we did, we do a show run, and let me pull this down just a little bit. We need to just find the object groups. All this stuff, okay, so you stop right there. So all this right here, let me go ahead and scoot to the top here, and right here. We go ahead and pull up Notepad, or no, go away. Everything's like, everything that you want to look at is, it's like, go away. So we go ahead and open up a new window here. So we're just going to put this all in here and expand it out, so it's a little easier for you guys to read and get rid of all the junk in here that we don't need. And so that's going to be this, and we're going to come in here and do this, and we're going to come down here to this. We technically don't need these guys here, are there and available, but when we applied them it didn't work. So we have our object, we created, let me go ahead and zoom in a little bit. So we have our network object, our object network, and then we named it. We created the subnet that we want to. So this could be a host, this could be anything else that's out there. And then we created several of them. Matter of fact, let me just go ahead and get rid of these because they're actually not being leveraged. So we did that, and then we created a object group where we said, you know what? We need you to go and create a network inside. So it's an object group, and we want you to call the objects of VLAN 10 and VLAN 20 together. And then we have the object group service, and we're calling it web via TCP. We're saying call be open and enable for web. So let me come down here a little bit further. Let's scoot this over just a touch. See if I can get it all in, at least the majority of it. So the first one here, we have ACL in from outside. We are saying permit extended permit ACL in from outside, extended permit TCP from any source to the object group of inside. So we're saying, I don't care really what it is, I need you to just allow it through. And as long as it's going, as long as it's TCP traffic going towards the inside. Now, one thing that will not work, in case anybody was wondering, if I was to hit the up arrow, I'm not going to be able to ping test 9. That's not going to work, and I'm not allowing that communication through. I could add a service object to that or create an explicit ACL entry to do that if I needed to. Sorry about that. I didn't realize I was still muted. So what was happening was with the ping didn't work, and the what do you call it? The ping didn't work because there's no ICMP entry here for it to allow it to come through. Then, so I could add an entry in if I wanted to allow ping, but that's we know what the problem is. We know how to fix it. Now, with the rest of this stuff, we're saying ACL in from outside. We're saying I want to allow traffic inbound from the outside, and we're saying any source. It doesn't matter what it is, right? We're allowing that inbound. But in order for it to work, it needs to be TCP traffic destined to anything inside of the inside object group. The inside object group calls VLAN 10 and VLAN 20, and inside of those objects we have 10.100.10.0/24 and 10.100.20.0/24. Now that allows that traffic in from the outside to the inside. We also have another statement that is TCP traffic going from any source to the object of DMZ. So we're one level removed. We're not calling an object group, we're just calling an object, and that object calls the subnet of 172.16.30.0/24. Then we come down a little further, and we have the next one, which is the in from DMZ. Now this is more explicit in its configuration, and the reason why it's more explicit, and let me go ahead and move this up just a little bit, is the reason why this is more explicit is because we're talking about it from the perspective of, and you can make this as explicit or as inexplicit, or I'm not sure what the or as generic as you want, specific or generic as you want. And why I say that is because normally you're not from the outside. This to me would be could potentially be a legitimate configuration for an organization. So you're saying permit TCP traffic from any source, and you have to specify any source because you don't know where the traffic is going to be coming from. If you wanted to try to be specific, you would have to be able to block out the subnets that are going to be traffic is going to be coming from. Well, the internet's a big place, and you probably aren't going to know all that information. So instead of being able to sit there and go, now you could block like by country if you know all the subnets that that country owns or potentially has in it. You can do that. Or you can do this and just say, you know what, as long as it's TCP traffic going to the inside, I'm good. Normally you're not going to say inside, it's going to be DMZ from a security perspective, but at any rate, you get the point. So it's pointing towards the inside. Now with the DMZ traffic, same concept. You're saying TCP traffic. Now the firewall is basically just opening up a hole and saying, okay, you can pass. It's not doing any advanced. So this is literally layer 3 and layer 4 inspection. Are you coming from any source? Yes. Are you a TCP flow? Yes. Are you going to a destination of, 172.16.30/24? Yes. Permitted. That's it. Now, in most cases, what I've been demonstrating for you guys so far has been just routed connectivity without NAT. So that's one of the key factors here. It's without NAT, and you need to make sure you remember that, because when we start NAT in an upcoming video or two, I'm not sure if I'm going to take this any further than what I've already done, because everything that we've done so far for this configuration here can be mapped to a object group, to the global ACL or to the outbound ACL. Or I should say, the ACL is irrelevant, or the ACL can be applied to any interface you want it to be, and it's just to any can be applied inbound to the global ACL, or globally, or outbound. It's up to you to determine how you want the ACL to process the traffic. Once you made that determination, then you can proceed. So here we're saying we're being a little bit less granular. We're saying TCP, are you coming from any source? Yes. Are you a TCP flow? Yes. Are you going to a destination of inside? Yes. Permitted. Same thing with the DMZ. And now, when we talk about in from DMZ, this is a little bit more strict, but it could be just as loose as this one. So here we could say any source. But we know the source, in this case here, is going to be DMZ. This is a good way to try to eliminate any type of spoofing or issues that might come in play. And you're saying an object group of inside. So this is the destination. And then you're saying object group web. So you're saying, is this going to web or HTTPS? And the answer is yes. It was going to the web server of both routers, or all three routers, I should say. So that's where that would come into play. So I also would have the ability to open up a telnet connection from, say, test 12 to test 9. So let's actually, while we're sitting here talking about it, let's go give that a whirl. So here I am on, I can ping 10.100.10.9. I can ping it, so I should be able to open up a telnet connection to 10.100.10.9. And it says connection refused by remote host. So we'd have to go check and test 9 and see show run section line. And that's the problem. So line VTY 0 space 4 and transport input all. Go back to 10 or 12. And then, so there's no password required, or no password set. Oh, that's because I didn't specify it correctly. Let's type in login local. Try that one more time. Here we are, Rob and Cisco, and there we have it. So there's the connection, and it does work. So we know that it's operational as well. So that just goes to show you that the config is working. And if I was to pull up the ASA, there would be an open session for that because it's an open TCP connection still. It's active. I can still send data back and forth. And that's the point. So that's pretty much where I want to leave it at this point, because I think we've broken it down again. And then all we have to do when we're doing the testing from the DMZ to the inside, I was like, why is this not working? Oh yeah, I forgot to apply it. And that's one of the key things. You have to remember to apply the ACL to the correct interface in the right direction. So you notice you have to always specify the directionality of the ACL, and then the interface is going to be applied on. So that's pretty much it. That pretty much hones this in. So we could have applied this to the global ACL. We could have applied this outbound, and it would have worked too. However, if we would have applied the ACLs with the current logic they're written with, traffic would have failed. Because you got to remember, when we're talking about communication through the firewall, when we're talking from a low security level to a high security level, as traffic comes in on the inside, or it comes in on the ingress interface, if it's going from low to high, the global ACL is going to drop that. That's what's dropping the traffic. If you are allowing it inbound with an inbound ACL, but then you're blocking it with an outbound ACL, we could have changed the logic in the outbound ACL to fix that. So these are just some of the things you got to keep in the back of your mind when you're thinking about ACL logic. Is it going through? And really, it's not so much the ACL logic that the problem is, especially when you're first learning this stuff. It's how the ASA processes it. That was my big sticking point. I was like, why is this not working? And I thought the global ACL was the devil the first time I played. I was like, this sucks. Because I ended up breaking a customer's network by inadvertently not knowing what it was. But then I was like, okay, Rob's going to stop and study. I did that. I learned how all this stuff works. And now it's been probably a year and a half, 2 years, and now I'm starting to put material out online for it. So, there's that. So I've covered the access rules that I'm comfortable with covering, and then what we got to do is, we're going to be doing some NAT videos. Obviously, we're going to be covering how that comes into play, and getting rid of the routing. And then we have quite a bit of material coming up for traffic inspection. So, as it sits right now, everything is good to go. I've been having a blast. You guys have been commenting and stuff like that, and I've been answering your questions as they're coming along. Keep asking questions, and until next time, guys, take it easy.